Hello everyone. This video follows a series of videos which we have done for EMI EMC analysis. In this video, we will simulate an example of irradiation effects inside a vehicle. So please open the previous example which you have solved, which is the crosstalk, and we will use the same file and modify it to represent a vehicle and compute the irradiation effects. So this is the file for the crosstalk, which is the example 4 in this series. So save this as a different name and remove the S parameter configuration. So right click and delete. Let's make some changes to the variable since we are going to have a partial automobile in the simulation. Having the units as millimeters will not help, so we have to change the units to meters. So let us accordingly change the variables h and L to represent meters. Change h to 50 e power minus 3 and change L to 100 e power minus 3 and change the units to meters. Delete near field request and the plane wave source. Change the conductor thickness and radius as well as the shield thickness. Remove the ground plane since we are going to bring an automobile in there, so we do not need the infinite ground plane. Now let's change the solution to irradiating. Since it's an irradiating case, let us remove the voltage sources and the ports. So since it's an irradiating case, the cable will act as victim, terminate both sides with the resistor. The irradiation setup is complete. Now the setup is complete, so let us bring in the body in white of the automobile into the simulation. To do so, click on the component library and choose car back. Click add to model. It'll bring the car into the model. Provide the destination as 0, minus 0.4 e power minus 3 and 0.9 e power minus 3 and click OK. So here you can see that we have brought in the body in white of the automobile with the cable inside. Next, let's bring in a windscreen antenna. I'm just going to pick a tag antenna for now to represent the windscreen antenna. Click next. Give it a frequency of interest, maybe 125 kilohertz. Give it a single frequency and hit add to model. So this will bring in the tag antenna into Feko. It'll bring it at 0, 0, 0. So let's move it to a position in the windscreen. I'm going to choose an arbitrary position just to show this concept. Click on tag, go to transform, translate. So give it a position 0, minus 0.4 and 0.9. So that brings it close to the windscreen. So it need not be perfect. It's just a proof of concept. So I'm just putting it in an arbitrary position on the windscreen. Click OK. So that brings the antenna here. Delete tag 1 FER configuration and here add a voltage source that will set a source for the antenna. Change the frequency to single frequency. Let's set up the new far field. Go from minus 90 to 90 and 0 to 180 in increments of 5 and hit create. So this will generate the far fields. We left out one thing where we need to add the voltage and current probes to measure the induced voltage or induced current. So click on the schematic and include a voltage probe and a current probe in the schematic. Keep the voltage probe across R4 and current probe passing through R3. This completes our setup. So now let's run the simulation. The simulation is completed. Click OK and click on Post Feko. Now click on Cartesian and click on the current probe value. This is basically the induced current inside your cable. And this is the induced voltage inside the cable. And you can look at the far fields radiating from the antenna. This completes this example. Thank you for watching.